Hello, viewers. I hope you are fine. Myself, I'm Harishankar Naikalapu, and my teammates are Chandana Chirmamilla and Manisha Kotamani. And today we are here to discuss about blockchain technology. Our project is about resolving the scalability issue of blockchain technology. Okay, let's talk about what is blockchain. Blockchain is a distributed database that is shared among the nodes of computer network. It stores data in a digital format electronically. The typical difference between the typical database and blockchain is how data is structured. A blockchain collects information groups called blocks, which hold set of information. Blocks contain storage capacities, which filled are closed, linked to previous filled blocks, forming a chain of data known as blockchain. Different types of information can be stored on a blockchain, but the most common use for has been distributed ledger for transactions. These centralized blockchains are immutable, which can't be reversible and permanently recorded. Okay, coming to the next slide. Our project deals with the issues of scalability in Bitcoin technology. The Bitcoin scalability problems refers to the limited capability of the Bitcoin network to handle large amount of transaction data on its platform in a short span of time. It is related to the fact that blocks in Bitcoin blockchain are limited in size of frequency. Okay, and coming to the uh, third slide. Yeah, the solution of the scalability issue that are using in compact block relays, which is one of the effective approach proposed by BIP 152. This will alter the entire data structure of blocks that are presented in Bitcoin. The solution in detail will be explained by my teammate Chandana Chirmamilla. Thank you.
Thank you, Hari. And coming to the next slide, I would like to continue from block comparison. There are many solutions to enhance the scalability of blockchain, and these are categorized into three layers. There are layer 0, layer 1, layer 2, and layer 0 focuses mainly on the data propagation. Layer 1 focuses on the solutions of the concentration of the features of the block data, as well as layer 2 is considered on the solutions which include the crossing characteristics. In this ppt we are going to explain about the layer 2 solution, which enhance the scalability and explains the characteristics of the blocks. For example, let us consider the increasing of the block size. In this paper, we focuses in this layer 2, which is in blockchain we have an effective technique which will enable to achieve this same solutions that are obtained in the increasing value. But it will also reduce the size of the storage overhead, thereby enhancing the block. Coming to the next slide, compact block relay. And this one of the block comparison techniques, and the same has been propagated by BIP 152, and consider it mainly focuses on the two factors that are block header and transaction ID, which is utilized by the transactions and enabled in the entire receivers. To maximize this bandwidth, we have two latency improvements which are low bandwidth relaying and high bandwidth relaying. In low bandwidth relaying, we generally present two things, that is block header and transaction id, which provides two nodes to compact this block relay. By considering these two nodes, let us take an example, node a and node b. When a node a attempts to send a message to node b, whenever an error whenever a receiver gets a block message, it will automatically gets entire the transaction into unstructured format. Coming to the next slide, compact relay control. The difference between the high bandwidth relay and the low bandwidth relay is that it will send only whenever the receiver sends the request from the bandwidth relay. In the manner, by the using this protocol, we all have that unwanted block, and the data will be associated with the reconstructed by compromising this compact block relay. And the coming next slides will be explained by Manisha. I would like to continue, Manisha.
Hello, my name is Manisha. So I'm going to present about low bandwidth mode. In the low bandwidth mode is mainly utilized whenever the P tends to utilize the blocks. Whenever a new node will be learning about a new block, then it will be announced the header hash of this particular block in the BIP 152 low bandwidth associate. Only when an associate requires that the compact block relay will tends to send the additional data. ultimately, this will avoid the sending the redundant data to the peer who has already received the block. And when coming to the next slide, this is high bandwidth mode. Next slide, please. Yeah. In the high bandwidth mode, the blocks will be utilized only when there are only a few users in the network. Whenever a piece will not be able to receive a block, then it will be verifying the header with a valid proof of work, and then without performing any further verification, it will immediately send this block to the user who are presenting in the high bandwidth mode. So this mode allows the blocker to propagate very quickly, thereby avoiding retransmission of the blocks through the nodes that are associated with the users who have already received the block. So this high bandwidth mode will utilize very low bandwidth. Also, there are two variants of a compound blocks that are used by the BIP 152. And when coming to the conclusion, this our project is about the distributed ledger can be handled by the blockchain technology because of increasing in the interest in the bitcoins and Ethereum. Blockchain technology has encountered a few of issues and results in a scalability issues. The maximum throughput and the latencies are regarding at the most important characteristics to consider with the analyzing a blockchain network. To address the scalability issues, the size of the block, bandwidth, and the latency of the blockchain technology must be reduced. The VIP 152 protocol operates in two modes, reducing the amount of redundancy data transmitting to the blocks, and additionally, the BIP 152 improves the speed with which the block is transmitted. And thank you. We have we have came to the end of the PPT presentation.
Thank you, Manisha. Thank you, Hari.
Thank you everyone.